Okay. Just a second. I know it's most likely fine, but I just want to wait. Okay, there we go. Until I can confirm that YouTube is also live. Cool. So, yesterday we had some issues with rendering multiple pipelines. Today, we don't have those issues anymore. This sphere is actually being rendered on a separate texture to the rest of the level, and then it's being composed. Although it still seems to be affected by light, which is interesting. But yeah, that's all good. That means the debug layer is working. So that sphere is technically on the debug layer. I don't want to draw this kind of stuff. That's like a really high poly sphere, I think. Can't even see the polygons. But basically, there was a couple of issues. Before we get into that though, there was this problem where I said that there was something wrong with the... Well, I admitted that it was most likely my fault. There was something wrong with the uniform buffers in the fragment shader. So if we have a look at the fragment shader here, 3D fragment shader, there we go. So I had a uniform here, and I thought I couldn't get it working, and the reason is because the fragment shader requires a different set, which is set 3 for the fragment shader uniform buffers. Hello, Hommanner. Sorry, that's a hard name for me to read. Yes, this is the SDL GPU in Odin, the new SDL3, sorry. So you can see here we've got we've got our pipeline creation, making our default pipeline here, making our debug renderer pipeline here, and then there's a third pipeline which is to compose those two together. That's this one. And then the drawing code is all down here. So yeah, the problem with the uniform, I believe, I haven't tested this yet, is that I was using the wrong set. So uniform buffer object, am I on Windows? Yes, I am on Windows. So we want to move this over here. We want to stop setting them from the vertex buffer. The reason is because it'll do that for every single vertex, whereas we only need these values once in the fragment shader. So we're not going to get this anymore, which means anything to do with player position, which we didn't even have. Light position, I'm pretty sure we're using down here. We'll use the uniform. Now our MVP structure, I'm going to remove this because that's not correct. And we're going to player position, light position. I think there was a commented code down here. Player position, light position, there we go. I've got to make sure that we are defining that we need a uniform buffer in the fragment shader. So that is default pipeline, fragment shader, uniform buffer is 1, that's correct. I'm probably forgetting one step somewhere. We need to upload, where is it? Push, yeah, SDL.push GPU fragment shader uniform data. There we go. And where was it? I uncommented it. It's up there, fragment shader uniform. So I'll probably just, I'll just leave it there for now, actually. It's fine. What is this? It's a slice. Okay. Okay, and then we need to pass in the length, which is 2. No. 1. Length. What is the length? I mean, it's 2 vec4s, but we're passing in 1 of them. What did I do for the vertex? Is that length as in size? Alright, so we need the size. Okay. If we go to the... not there. I guess I need to find it in this file here. Length is the length of the data. So it must be in bytes. So we got 2 vec4s, so we'll just say vec4 times 2 for now. What's the problem with this? Expects a string, slice, but we got a... What's wrong with this? Well, that will work regardless. Okay, so this should hopefully work. Let me just build it again, make sure there's no errors. There was an error. Unexpected vec3 on line 13. Because I forgot the semicolon after the layout. There we go. Oh, another one. 56. Assigning from a 4-component float to a 3-component float. Fair enough. Okay, good. Nope, apparently not good. We need this, please. Let's see. Set to binding 0. It's invalid. Why? GLL cell to spear V to SDL GPU. Well, SDL GPU is not a shader language, so GLSL to spear V, yes. I'm using Vulkan as the backend, and SDL is the abstraction of the graphics API. So the problem here is that apparently this is invalid because the descriptor in each must be valid. Was not created. Oh, I need to check the... I might not have set it in the pipeline creation here. So using Vulkan backend for Windows. Yes, that's right. got the number of uniform buffers. What's the problem again? It's not a sampler. Hey Chad, you want to say thank you for the helpful videos and you started working on your own engine? Awesome. You're very welcome. Thanks for saying thank you. What's your engine? What's the goal, I mean? That's the wrong set. I'm supposed to bind to set 3. That could be why. Yeah, would you look at that? 3D voxel engine? Want to make a Dark Souls Minecraft? That's awesome. That's great. Gonna take a long time. I'm also doing something not exactly similar, but kind of similar. I think I have this old version here. So, oh, it doesn't run anymore. Why? I think I deleted my shaders. Okay. Damn. Let me grab this file real quick. Alright, so I need... yeah, the old version. I need this, and I think I need GLSL. Okay. Don't remember what the other shader was called. Okay, I'll just save this one first. I'm just doing it on the other screen. 1 second. So what's going to happen if I run this? marchingcubes.com.glsl failed to open file. Didn't I just save that? Oh no, I saved the triangle list. Whoops. There's surely going to be 2 other shaders missing. The vertex and fragment shader. Yeah, simple. Okay. Gotcha. Okay, hopefully this will run now. There we go. Okay. Yeah, so here's the terrain generation I was working on earlier. It's totally not done, but this is using voxels as well. But I just decided not to render cubes. So instead I'm rendering using marching cubes. So you get sort of slopes. The lighting is all fake. It's just using the normals. But well, I guess that's always the case. Yeah, this is pretty fun. I based the terrain generation on, whoops, I didn't want to rotate, on the video by Henrik. He's the, I can't remember his last name. He's the guy who made the Minecraft terrain, basically. I'll just show you the video real quick on here. In case you haven't seen this, definitely check it out. This video, Minecraft terrain generation in a nutshell, by Henrik Debug. It goes over how they actually calculate the height of the terrain, and they use these splines and add them together. Where was it? Here. And it's really cool. Definitely look into it if you haven't seen it. And oh yeah, so I need to get back to this state, which I will. But right now, I was just working on loading models and lighting, and also fast noise. Are you using fast noise too, or the first one? It's pretty cool. I mean, it seems very fast, but I don't really like the usage. I can't remember. I used it a while ago, but yeah, there was something I didn't like about the usage. I think maybe because it was C++ and then I had to wrap it or something. I can't remember exactly. But yeah, that's cool. It's cool to see people working on interesting stuff. Hello, helium? Okay, yeah, I get it. Took me a second. How is SDL treating you? It's pretty good. I like SDL3. I've just been informed that apparently it's not as good as Vulkan, which I didn't really expect anyway. But I actually think it's sort of like a nice stepping stone. So I'm not sure how comfortable you guys are with Vulkan, but do you need all the features of Vulkan? I'm not sure yet. I'm just going to use SDL3 until I run into a wall, and if that happens, then I will switch. But I mean, it's not that much. I mean, it's a lot less code actually, because you don't have to do the device stuff. So I guess if you use something like Vulkan Bootstrap, it would be kind of similar. So Vulkan Bootstrap gives you a library that just does all the finding the GPU and all that kind of stuff, setting up the surface and etc. So SDL3 does that with just create GPU device, which is nice. So I guess, love how cross-platform it is. Yeah, it's pretty good. All right, so you've already done a bit, yeah. So it's actually not too dissimilar in usage, I think. You still gotta set up your create info structs everywhere, create your shaders, create your pipelines. But there's just a lot less stuff because it's not as flexible. So I was looking at this in the documentation because this is really important. You've got set slots for resources. So sample textures are in slot set 0, uniforms are in set 1 on vertex shaders, and fragment shaders are in different sets. So if you don't pay attention to this, which is what happened to me yesterday, then you're going to run into problems. But yeah, so far I like it. I think it's a good kind of midway point. Use HLSL and all you need to do is compile the shaders to SPV and DXIL and it just works. Yeah, it's pretty good. Yeah, I'm using GLSL because I was following some stuff in here in this OpenGL tutorial, and also I pretty much only used OpenGL previously, so just makes sense. Okay, so I think we're good. We've got 3 pipelines and they're working correctly. Now the thing is, I don't like the sphere. Well, I mean, I don't mind the sphere. The sphere is fine, but I want to draw debug shapes, not really high poly spheres. So how would I go about this? I want a function, I want the functionality to draw a debug sphere at a position, and it would be like a wireframe drawing. So I guess actually on the debug pipeline, I could set that somewhere. Where is it? There is a way to set this somewhere. Is it the color target info somewhere? No. The rasterizer, perhaps? This is the wrong pipeline. This is the correct pipeline. So I want actually fill mode to be line, and then don't cull, I guess. I'll just delete this. Will that work? Let's see. Okay, cool. That is a crazy high poly sphere. Wow, look at that. That's insane. Okay, definitely not going to be using that. I just downloaded the model from the GLTF examples. It's where I got the sponsor from. There was a sphere as well. I just downloaded that, but you know, I was just watching a cool video recently, just this morning. Let me find it actually. How do I find this guy's channel? Here we go. So this person, Versidium, he makes some cool videos. These thumbnails work surprisingly well, which is cool. Really good. But the thing I was talking about was actually this one here. So he creates, the sound is off anyway, but basically he uses the shader to draw planes, right? And then he has like uniforms that he was passing in to make them bend and stuff, because he's making plants. So he wants to make them sway in the wind. And he has some pretty cool tricks for making this fun, which ends up looking quite nice. And the thing I'm interested in actually is sort of this part here, which is just using the vertex ID to construct geometry. So we could make a quad without passing in a vertex buffer. And so I got something that's not quite like that in the vertex shader, which one? Full screen quad. I've got just hard-coded positions and UVs here, which I guess is fine for what I'm doing. That's for rendering the final image on the screen, because I'm actually composing the two together. So there should be a where is it? There's a simple 2D. Did I call it that? No, surely not. Oh, it's actually this fragment shader here. So I've got the two textures, and then I just compose them together here in the fragment shader. That's how I've got the debug layer. Chad asking, how do I import my models? I am using CGLTF, which... That's alright, I'm not going to say anything about that. I just wrote this function that loops over all the meshes, and then loops over all the primitives, and finds out how many vertices and indices there are, and then allocates some buffers and does some transformations based on the root position of the model, because not all the vertices are stored in the correct... It seems like they're stored sort of relative to the 0 position. I mean, not relative, or yes relative. So you're going to add the position or something like that. I can't remember exactly now. But it was kind of a pain. I actually hate this format, and I understand that it's not really... I'm not the target audience for this GLTF format, because it's designed for like full scenes with animations and all kinds of crazy stuff going on. And I'm just like, I just want vertices. I don't want any of that. So I didn't want to have to make like an accessor node thing and then like do some weird stuff. Anyway, it's alright. So for now, I'm just using this function that I made, but I think eventually I'll probably make a different format, because I don't think models in my game are going to be super complicated. I think they'll just be really simple actually. So I might just make I might either just use OBJ or make my own format. I'm not sure. Looks like a pain. You used ASIMP. I always love the name of that. But it's also kind of painful, yeah. Helium says the problem is there are not really many formats out there that are good and open. You kind of have to make your own. Yeah, everyone seems to make their own formats, which I don't mind, because I find that kind of fun. So it doesn't really bother me. So I'll probably make a Blender export if I end up using Blender, and then just make some simple format that works. But for now, we're just testing, so I just use these GLTF models. So that problem is fixed. The not that problem, the other problem with the uniform buffer. This is working correctly now. Great. The next thing I wanted to work on was, yeah, as I was saying, perhaps using the vertices in the shader to draw something like a sphere. I could probably just do something really simple, like I'll just make a random file here, like sphere vertices equals whatever, and then actually just make like a little wireframe sphere that doesn't have that many polygons. But that would mean I'd have to know how to draw, but I'd have to know when to draw a sphere versus when to draw something else. So I guess maybe we'll just start with drawing boxes, because boxes are easy. Hello, Alex. You paused GLTF on your own. I don't think that sounds like very much fun, to be honest. Although I do like pauses. I just don't like the format. So let's think about this. Right now, hang on a second. That's interesting. I can see the light moving on this sphere, but not on the level. So we broke something, actually. Huh. Drive and shader uniform, yeah. Am I in the wrong render pass here? Yeah. That's the wrong render pass. So I just uploaded this to the debug render pass for some reason. I don't want that. I want this here. There we go. That's better. OGL Dev had an interesting vid about making the grid in the shader worth a watch. Yeah, okay. I'll check it out. So, cool. That's working. That's fine. The thing about the debug situation is... No. Let's not get too ahead of ourselves. All I need to do is draw something using the debug shaders, which I'm going to make here. I'm going to make a simple, I'm going to make a debug shader. So I guess I will... What's the simple 3D shader look like? Simple 3D vertex shader. Yeah, it's pretty simple. So it's actually the same. I probably don't need to make... Oh no, I do need to make it a separate one. We don't need that. Why is that even in here? Oh yeah, because we were passing it. Okay, now they look exactly the same. It's going to be very confusing. We're not... Maybe we are going to send... I don't think we need to send a frag position. That was for lighting. We're not going to light the debug stuff. We still need model view projection, I guess. But this is assuming that we're going to be sending in a vertex buffer. But what if we want to not do that? That's probably still the easiest way. Not sure. Not good enough with shaders yet. So this guy says you can construct just basically lines of triangles like this, which is really cool. So I guess I could just... Okay, I'll try to do this. I'll just try to do exactly what he's doing right here. And then we'll see if that works. I think the Vulkan GLSL also has vertex ID. Not 100% sure. Oops. Okay, let's have a look. So MVP is here, that's fine. We're going to say position is vector 0. You know what I don't know, and I said this yesterday, is I can just put 0 without the dot, and I do it all the time in the shaders. But I noticed that a lot of people use the dot, like use the decimal for values like 0 and 1. So is there actually a problem with that? Is there going to be some version that it doesn't work with? But it's compiled to SPV anyway, so it should just be fine, right? Alright, let's just get this really simple version working first. Not a shader expert, so you don't know. Fair enough. Me neither. I wish I got into graphics programming much sooner. It's really interesting. But then I guess I wouldn't know all the other stuff that I know, so it's It's fine. Alright, so we're just going to do 0 and 1. You always burn out when you attempt graphics programming? Yeah, me too in the past. Okay, so I'm going to change this position to this position. And then we're gonna draw 4 vertices. And we're not even gonna have buffers coming in, although with no color. I guess you could set that in the uniform, right? Okay, I'll leave it like this. I need to make a fragment shader for it though. Was it called Debug? Yeah. Wait, I've already got one. Hang on a second. Oh, I already had a debug shader here. Debug.vert.gsl, GLSL, and this is debug 3D. Well, that's silly. Alright, so I'm gonna just copy this. Sorry, I'm having a hard time reading a name because of the color and the background. Coco Canelo. Hello, Coco. How you doing? Alright, so I will delete that. I'm gonna delete the debug 3D shader so I don't get confused. There's too many shaders in here now, jeez. Debug 3D, there we go. Okay, there's a problem. GL vertex ID doesn't exist anymore apparently, okay. Maybe it's just in Vulkan that it doesn't exist. Using SpearV with OpenGL, GL vertex index is always 0. Right. Okay, so vertex index and vertex ID are the same thing. Apparently, that's good. So we can change this to index. That's a lot of errors. Requires location for user input output. Okay, let me check. Cannot determine the shader stage. Oh, that's fine. Non-opaque uniforms outside a block. Quite a few problems in the simple shader. Oh yeah, that's OpenGL, that's why. So these ones I can just ignore. Because they were just for that terrain demo that I showed. So they're different. Debug underscore 3D, yeah, okay. So if I change this to debug, build again, we should get, all right, we've got a build, that's good. This is going to be really annoying. I might just delete those again. Actually, I'll just leave them there, that's fine. Cool. Wow, it worked. I think it's a bit incorrect, but we got a little quad. Oh, can't really see that. There's a, well, it's not really a quad. We got 2 triangles on the floor. I'm gonna have to change the ordering, I suppose. That's not what I wanted. Huh. Did you guys know that there's Google stuff in here? GL Google, CPP style. Oh, it's just a style? GL Google include directive. Okay. Very strange. Okay, so the problem is the triangles are overlapping. So let's think about this. Position 0 is fine. Actually, I wonder, can I set a out? Can you do flat out? Int? Vertex index? Or is vertex index available in the fragment shader? Let me see. This is not the right. This is OpenGL. Okay, that's fine. Right, so you got fry coordinate and stuff. So you probably have to pass it. Probably. I'll just pass it out, that's fine. What is it? GL vertex index, it's an integer, right? Okay. Fragment shader, there we go. Why do they make it so complicated between backends, windings, matrix, row, column, order, and coordinate systems? It's like they don't want people to learn this. Yeah. Yeah, it is really annoying. I guess it's because everyone thinks they have a better idea. They're not really working in tandem with each other. I think I just get in. I'm just gonna say that's what was it? Vertex index. Okay, so I can just do something like this. If vertex index is 1, then actually let's do this frag color. I just want to see if this works. Okay, of course. Int must be qualified as flat in. Okay. So it's flat in and out flat, or is it flat out? That's a bit confusing, isn't it? Let's see. So that's fine. Where was it? Compile, debug. Yeah. Apparently it's fine. Okay. Well, doesn't look red to me. Maybe because it's wireframe? I would have thought wireframe would still be colorable. What if I just change this to red? Okay, yeah, that definitely works. So, obviously... Oh. There we go. That's the problem. I was passing the original value, not the modified value. So... Well, let's That was a problem. Doesn't seem to have solved it. Else if in vertex index is 2. I'm just experimenting. I just want to see what kind of stuff we can do with this. Okay, interesting. So we said one of the vertices is green, and now 3 of the vertices is green. It's interesting. This debugger is called the RAD debugger. The RAD debugger. It's free. It's better than Visual Studio and way better than stuff that I could find on Linux. It is not on Linux right now, but it's going to come to Linux soon. I'm sure a lot of you guys are I'm sure a lot of you guys are on Linux. But yeah, when this comes out on Linux, I might switch back to Linux. I don't think there's really a good operating system right now, but yeah, it is what it is, I guess. So let's see. This should totally work. Maybe we're not drawing enough vertices. No. Hang on a second. Is it that big a game changer? Yes. Yes, definitely. I don't know if you've ever tried to use GDB or GF2, or I even bought one, which was pretty good for a while, but I don't know what happened recently. Called CodeClap, which was not bad on Linux, but yeah, nothing really good. Ryan's UI stuff is impressive. Yeah, it is. The way he programs is really different to how I would even think of it. You know, it's hard to use. We did use it. Oh yeah. Fair. So what I'm not getting here is, if we're sending in 4 vertices, which we're actually sending in way more than 4, right? I think we're still rendering a sphere technically. There's a GUI version of GDB. Yeah, that's what I was talking about. I've tried a bunch of them. I don't think any of them are that good. The other debugger I would recommend is called Remedy BG. And I have that as well, and I use it sometimes, but this one is paid. I think it's worth the money though. So sometimes I use this because RAD is still in alpha, so there's sometimes some issues with it. Remedy BG is also Windows only though. And I just got a missed call. It's from a number I don't know, therefore I will not call them. They can email me. What was I doing? So yeah, when we draw this debug layer down here somewhere, here it is. So we're drawing the debug stuff, but we're drawing this many indices, which is just crazy amount. So I'm just going to say we're drawing 4. But we're not drawing index primitives actually. So we're going to draw... that's probably our problem. We're drawing an indexed buffer, which means we're getting an overlap. Okay, so we don't want an index binding. We just want draw GPU primitives. And we'll say 4 vertices, 1 instance, 0, 0. Nax has a GDB front end called GF. Yeah, that's what I was just talking about. I don't think it's, for me, it's not usable. It looks pretty good, but yeah, when I tried to use it, it just didn't really do it for me. Interesting. So we've got 3 triangles. Did we need to make 6? I don't think we did. 3 vertices rather. BDB is not really usable for you. Yeah, I can relate to that. Okay. Let's have a look at this again, because I feel like something really strange is going on here. So we pass in. Yeah, okay, I guess we'll just start from the basics, right? So we'll draw a line. And I'll use this cursed style as well, of not using braces. Okay, are we drawing a line? We're drawing a line. Okay, so 0 is here where the light comes up. We're drawing a line straight across to the positive X direction. Great. That's not what I wanted. Thank you. Okay. Now, if the ID is 2, then we draw at the positive Z. Okay, yeah, that makes sense. Now the thing about vertex index is, does this number increase? It's an index, right? So you'd probably have to mod these to make them wrap. Let me see. Let's just do this first. Okay, we've got our triangle. So the positive Z direction in our renderer is behind us, which makes sense, I think. Okay, so Z, positive X is that way. Fine. So far so good, right? Now, this last one. Is where the issue is coming up. And it could be because, let's look at our situation again. So if positive Z is that way, positive X is that way, then yeah, we want to do one more on the corner there, which is positive Z, positive X, positive Z, which is exactly what we did. Oh, you know what it is? I might not have been drawing triangle strips. I'll have to check that in the pipeline. Wait, does that... Oh god, I hate this. Can you indent 2 things underneath, or do you have to do braces? You have to do braces. Okay, interesting. That's what I thought. I'm just going to add braces. This is annoying. Okay, there we go. I have some flashbacks and PTSD about my old C programming style, where I would do if whatever x equals 32, and then somehow I would think, I can't remember exactly what happened, but there was some issue with this style where I would do really dumb stuff and there would be a bug, and it would take me ages to find it. Okay, so I need to find the pipeline. So it's called debug pipeline, right? No, it's called debug graphics pipeline. It's annoying when you need to add to it and you have to add braces, therefore I always add braces. Yeah, same. Yeah, so this is the problem. We want a triangle strip, not triangle list, because we're not sending a triangle list, we're sending a triangle strip. Okay, gotcha. Would you look at that? Yeah, that's too many vertices now. So where was it? Here. So we're sending 6, we need to send 4 to draw a single quad. Hey, look at that. Nice. Okay, cool. So interestingly, it seems like we can't do vertex coloring. It doesn't blend between them on this wireframe. So if we go to the fragment shader again, something like this. There's definitely no blending because it doesn't really matter. Just do ifs. Remove the else's. Well, then you're going to check every case. The reason to have an else is because as soon as one of them matches, it doesn't check the other ones. But yeah, I don't really mind about... I was just testing some stuff. It doesn't actually matter. True, it's late. Yeah. Cool. So we got a quad. That's cool. Now, how do we extend this to a cube? And then, just because we can draw it in the shader, like, would we want to have one shader that just draws a cube? That seems kind of crazy. So if I was going to follow, not this example. So basically he makes a shader that draws ferns, right? And he does this cool thing where he uses the triangle strip and then he makes this strip part invisible so that he has multiple strips of triangles next to each other, and then he can rotate them around and make this fern, which looks really cool. We're not doing this though. And so my concern is if we go down this route, then we're going to have a shader that can draw one cube at one position with one draw call. So I wonder how he gets around that, actually. Because I'm pretty sure you wouldn't want to... Maybe you talked about it, but I don't know. Because you wouldn't want to do one draw call per plant. That would be crazy. You just want to specify, I've got plants in these positions, and therefore I'm going to offset them. So I guess you could just set the position to be based on the vertex buffer position that comes in, if that makes sense. So let's say this was a cube drawing, well, let's just use a rectangle. This is a rectangle drawing, or even a square. We're drawing squares. Square drawing shader. And if we send in a buffer of 3D positions, then what we're going to do is draw one square at each of those positions that's the same size. They're probably using instancing. There's Nora. Okay, that's not quite clicking for me. So let's have a look. What is... Okay, I'm going to look at... I mean, I know what instancing is in theory. but I don't actually know how I would apply it to this problem. So we're going to draw index primitives. I already did this actually for something before. They're not compatible with built-in vertex instance ID variables in shaders. For example, SV vertex ID, GPU APIs and shader languages do not define these built-in variables consistently. So if your shader depends on them, the only way to keep the behavior consistent and portable is to always pass 0 for the correlating parameter in the draw calls. That doesn't sound good. That sounds like it might be a problem for what we're doing, but not entirely sure. So, first instance, the ID of the first instance to draw. I guess the easiest way to describe this problem is, okay, we can draw one rectangle, which is cool. We just drew it in the shader using this method that he explained here. How would I draw another rectangle next to it or in another spot in the world? Would I use like another, see, I don't want to do another render pass. That would be crazy. Imagine you're like doing a render pass for every individual object. That doesn't make sense. So I'm thinking you might have something in the vertex buffer that's just a position, and then it's going to use these positions to draw at each one, but then that doesn't make sense because you might as well just pass in the positions of the vertices at that point, right? Because this position changes or is sort of individual to each vertex shader run, right? Unless there's a way, I guess you could use a storage buffer. Yeah, you could use a storage buffer, right? So you could put a storage buffer in and you could say, maybe in a uniform, you could have the current instance of the thing that we're drawing as an integer, and then you could figure out which one you need to draw, get the position from the storage buffer, and then use that as the base position, and then you could add 1, 1, 1, 1 to that base position, and then these vertex indices would be sort of a you'd need to mod them, I guess. Can you even do that in GLSL? Remainder. So it's not under SDL's GitHub. You can look under the spy dog. Oh yeah, I know this. I was looking at this guy yesterday on stream, I think. Wow, thanks for research. Yeah, it totally changed it to like therapy dog, which is a bit weird. So you're like instanced indexed? Is that kind of what you're referring to? So let's have a look at the shader first. Position color instance. Where is it? Position color instance. It's HLSL, which I don't know. Okay, so this is a vertex. This is yeah, this would be the input from a vertex buffer. And then, wait, what? No, it wouldn't. I don't get it. Okay, I don't know how this instance index SV instance ID is in here. Like texture coordinate 1, texture coordinate 0. Yeah, this is definitely this is a value that you can get in the shader, but I just don't know what this is. Like struct input. Input to where, from where? You know, does this come from the CPU? I guess I could look at this side, which we were looking at just before. So let's have a look, see if we can figure it out down here. Okay, so we're gonna bind the GPU vertex buffer, which is gonna use this buffer, vertex buffer, which we upload to, and we pass in, where is it? Transfer, yeah, that's fine. We pass in position color vertex. So this transfer data. Okay. Upload to GPU buffer. Okay. Yep, that's fine. So this is a vertex buffer, I guess. And I guess this is just how you get the instance ID in this language. So instead of typing down here, SV instance ID, you actually get it as an input. So, okay. Yeah, and then they use the mod 4 to offset the position, divided by 4, floored on the y-axis. Okay, we can worry about that part later. So it looks like they basically do what I thought they would do, and then I wonder why it's called text code 0 and text code 1. So color, it's a position. This is a position. Position is this. Right. But if they're always passing in the same position, what's the point of sending this data? Unless they change it. I think a better resource for instancing and shaders would just be learn OpenGL. Alright, well I have that open, so let's have a look. Instancing. Okay, so you have a scene where you're drawing a lot of models. They contain the same set of vertex data, but with different world transformations. Yeah. Think of a scene filled with grass leaves, each grass leaf. Yep, I'm not going to get hung up on that. You'll probably want to draw quite a few of them. Yeah. I was going to need to learn properly about instancing eventually, because I have done pretty much everything by just smashing all the vertices, including overlapping vertices, into a big buffer and just drawing it on the screen. And, you know, you can draw like a million rectangles on a laptop. I mean, not rectangles, a million triangles on a pretty crappy laptop on an integrated GPU. So I just didn't really worry about it, but I think I need to learn properly about it. When drawing many instances, you'll quickly reach a performance bottleneck because of the many draw calls. Yeah, so that's what I was avoiding by just smashing all the stuff into one buffer. You just have one draw call. And then, yeah, you can get a lot of performance out of just that, but I don't think it's going to be enough. So, okay, yep. It would be much more convenient if we could send data to the GPU once and then tell OpenGL to draw multiple objects. Yeah, that's exactly what I want. Okay, good call. Okay. By itself, this function is a bit useless. Rendering the same object 1,000 times is of no use, since each one is rendered exactly the same and thus also at the same location. For this reason, they added the instance ID. Oh, yeah, right. We can use instance ID. When drawing with one of the instance render calls, instance ID is incremented for each instance, starting from 0. So from the 43rd, 40, that's not correct, but that's okay. I'm pretty sure English is not the first language here. GL, but the rest of the English is pretty good though. Having a unique value per instance means we could now, for example, index into... So text chord is a location in GLSL, I think. Right. I don't quite understand, but that's okay. We'll see if we can get something working with this. To get a feel for instance drawing, we're going to demonstrate a simple example that renders 100 2D quads. We normalize, well, I'm not going to use normalized device coordinates, but I'm sure I can figure it out. Cool. That's cool. Alright, so the shader is really simple. It's just the color. Okay, and then the vertex shader, they just use offsets, which is a uniform. Yeah, okay, this is exactly what I thought. Well, actually, it's not exactly what I thought. I was thinking we could use a vertex buffer, but now that I think about it, that's kind of stupid. I think we can get something pretty good. Okay, I think I understand from this. Let's see. So let's say we don't even care about what's in the index buffer or the vertex buffer. We have a uniform set equals 2, binding equals 1. And I'm going to call it offsets as he has there. I'm not sure if the format for Vulkan is going to be different, so I'll just I'll call this offsets. Vec3 offsets, and we'll just pass in 10. Okay, so the position is going to be the, I mean, maybe it should be positions rather than offsets in this case. So we'll do positions GL instance ID. It might be called something else in Vulkan, but I'm sure we'll find out very soon. Okay. Now the position is going to be, oh, I see. We need to actually add, I suppose, in this case. And this needs to be mod. So GL vertex index, mod GL vertex index. Hang on a second. There's got to be two parameters. Compute value of one parameter modulo another. Yeah, okay. So and won't this always be true if it's mod? No. It depends if it works the way of C or not. The problem is vertex index is going to increase past, past 3 as we pass in more vertices. So we need to actually change this to something like this, I think. But we might have to do it in reverse order, I think. Because let's see. If the value is 4, let's say the vertex index is 4, then 4 mod, yeah, we're using the wrong number here. This has to be mod 4 mod 4 equals 1. 0 mod 4 equals 3 though. I'm having a brain fart here. The keyword is really messing me up. So usually I would do if some number mod, and then I want to find if it's multiple of 4, then I would do this, right? And then 3 would be fine, like this. Okay, so I think I would do mod n1 equals 0. But now we've got a problem because everything is a multiple of 1, isn't it? Which is why I was saying we should do it in reverse. So let's do that first. I'm probably wrong. I'm probably doing something really stupid right now. Three, 0, and then so that'll be every even number, which is not what we want, I think. Because it's not what we want, because that will also include 0. What is... So let's just do it in here. Can I do it in JavaScript? Hello? Okay, apparently you can't open the developer console anymore. Oh, there we go. I was probably pressing the wrong button. So 3 mod 1 is 0, 3 mod 0 is nan. Okay, 0 mod 3 is 0. 0 mod 2 is 0, 0 mod 1 is 0. 3 mod 1 is 3 mod 2 is 1. That's what I would have expected. 3 mod 1 is 0. How does that make sense? Does it work differently? So 4 mod 3 is 1. 3 mod 3 is 0. So this would be 3 mod 3 is 0, right? But if the vertex index is 2 and it comes in, then it's going to be 2. So 2 mod 3 is 2, which means this is going to fail. 2 mod 2 is 0, that's what we want. And then 1 mod 1 is going to be 0. But what about 4 mod 3 is 1? Okay. I think maybe this will work. Well, let's just try it. I'm probably forgetting something. So I'm actually going to remove this for a second. And I'm going to comment this out for a second. And I will just run it again because we should see if that worked. That did not work. Okay, interesting. At least not the way I thought. Oh, yeah, because we need to actually subtract. Oh no, we added 2. Well, that's probably one reason. Okay. We have a triangle, which is not what we wanted. The reason is why. One of these is working on 0, I guess. So if I can just do something really stupid here, which is GL vertex index. We don't do anything. Okay, that didn't work. I thought that was what the problem was. Right, so we mod GL vertex index with 3. So that's the multiples of 3. You know what we should do actually? I think we should do this. Int index is GL underscore vertex index 4. Now that'll give us a value between 0 and 3, inclusive. So we can just go back to the code that we had before. I think that'll work. Error compiling the vertex shader. What is it? Cannot convert from float to int 23. Oh, apparently this is a float. Huh. That's interesting. Is this... What happens if I cast it to an int? I have no idea what the value is going to be now. Yeah, that worked. Okay. Okay, success. Great. That's what we wanted. Okay, so that's much better. That's a much nicer solution. Wait, no. That only worked because I left this in here. Silly me. Okay, it still works. Good. Did it compile though? Yep. Okay, good. Fantastic. Okay, cool. So, we can use our positions that we're going to pass in to draw multiple of these instances. Okay, let's see. So we're gonna... Actually, before I continue, I'm just gonna go to the bathroom real quick. I'll be right back. And I'll make another coffee, so I'm gonna mute it just a second. Okay. I'm pretty sure I missed you, Helium, but good night. So, we have drawing quads. The quads are just made from this code here, which is pretty cool. Now let's see if we can get positions to work. So the idea is we'll send in 10 positions and we'll draw a quad at each of those positions that we send in. We could even get crazy and send in some kind of orientation. But let's just do positions first. So uniform positions. Now that we're using 2 uniforms on the vertex later, vertex shader, we're going to have to change the pipeline, which is here. This is going to be at 2. I've got a uniform buffer on the vertex and the fragment shader here that we don't need. I think we don't use a uniform, right? No. So let's see. This should just work, and it should draw 10 overlapping quads at position 0, right? Which means we can't actually see them. We could do something like position.x plus equals, actually I can do it here. Oops. Position. Wait, why did I? Okay, yeah. Position.x plus equals float index. No, not index. Float gl underscore instance ID. I just want to see if this gives us an offset for each instance. Error compiling the shader. Why is that? Did you mean instance index? I guess I did. Okay, that worked. Ooh, what did we miss? Set2 binding 1 is invalid. Really? What's wrong with that? Two uniform buffers on the debug renderer, yes. And then I'm pretty sure I don't have to push any data to it, but I'll try push data to it anyway. I don't think that was the error though. The error was that it seems like it's not set up correctly. What is this? Vertex binding. Debug vertex buffer. We're not using that actually. So we'll push one of these to slot 1. It's going to be positions. And we'll say it's the size of vec3 times, oh, it's got to be vec4. That's probably the reason. Because layouts all have to be std140. That could be why. So positions is just going to be an array of 10, float 30, no, vec4. And that'll just be 0 for now, I guess. Okay, there was an error. What did I do wrong? Ah, yes. Positions dot xyz. Okay, still a problem with the descriptors. When we try to draw, uniform positions is invalid. So, descriptors must be valid as described. Created with pipeline create. Okay. Still getting the hang of reading these Vulkan messages. They're a bit confusing. Let's have a look at the top one here. So, validation error, because when we create the graphics pipeline, this stage, which is the VK shader stage vertex bit, uses descriptor set to binding 1, variable uniform positions. Gotcha, but was not declared in the pipeline layout. Am I perhaps understanding that you can only pass one uniform? Is that what I'm getting here? Let's have a look. Let's refresh this page. It does say uniform buffers. Uniform buffers, right? Not one. For the vertex shader, so it's set. Oh, did I put set 2? I am silly. That's the problem. Alright, cool. We still have a problem, which is, well, what's happening over here? Robust buffer access is not enabled. The pipeline was created without robustness buffer, etc. Vertex inputs then. Okay. So something points to a null handle. Yeah, because we didn't bind a vertex buffer, I think that's why. Maybe. Because I actually deleted that code that was here. Where was it? This one. So maybe I'll add it back in for a second. Just so we have a bound vertex buffer. And then maybe it will not complain. Yep, okay. Cool, so we've got 1 quad. We don't have 10 quads. Which means our shader is not working as I was hoping. Is it compiling? Yes. So let's see. It's 12:30. I got half an hour left. Position is going to be positions. Index XYZ. Oh yeah. Wait. All the positions are 0. So therefore the position is going to be 0, but then we offset it by the index on the x-axis, so it should still be moving somewhere. What if I do something like this? So we'll do 0, 0, GL instance index. We're not drawing instance. I just realized we're not drawing instance. We're drawing primitives. We need to do draw GPU. Is it instanced? No, it's called indexed. Is that right? Or is it indirect? No. Oh, we're drawing one. Yeah, there's one instance. Okay, so we need to draw 10 instances. Okay. Oh, look at that. Nice. We've got a nice strip of rectangles. Well, it's not actually a strip. It's separate rectangles next to each other, but that's cool. Let's actually make everything in the debug shader green so we can see it. It's going to make this frag color comes from the vertex shader for some reason. Yeah, I guess that's fine. So we're just going to say, right, so it's a 0, 0, 0, 0. We're just going to say it's 0, 1, 0. There we go. Cool. Alright, that looks better. So now we can see some debug shapes on the ground. I have no idea how to profile this stuff. Maybe RenderDoc will help with that. But let's not worry about that right now. This proves that we can use this as an offset, and then if we populate the positions here, let's say we got a 0, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What's wrong with this? Oh, vec4. Okay, cool. That's what I wanted. Yep. Nice. Interesting. Now, what I'm thinking is, instead of wasting this fourth component of the vec4, we can actually put a number in here, and the number is going to tell the shader what the thing is that we're drawing. So, is that going to work? Maybe. So let's say 0 is drawing a rectangle and 1 is drawing a triangle. I mean, for now I'll just do a triangle. So we can say draw rectangle, and that can take position. Maybe I'll return a position. That's not the right language. Calculated. No, we'll just do position. Okay. So position is going to be draw rectangle if. Nope, that's wrong. Positions GL underscore instance index.w is equal to 0. I don't actually need to make a function. Let's just do this. Alright, else, I'm just going to draw a triangle for now, I guess. Except we're going to have to figure out how to send in a different number of things, because we're sending in position and we're drawing 4 vertices. But what if we want to draw something that has more than 4 vertices? I don't know, maybe we just overdraw a bit. I've got to think about that. In any case, we can grab this. We can say we're going to be mod 3. And basically we're going to do, I guess we'll just draw this kind of triangle. Sort of right angle triangle here. So if index is 1, then blah. If index is 2, then blah. I'm going to compile. Yeah. We should have a floating triangle here. Nope. I must have messed it up. Interesting. Maybe because it's a triangle strip? So let's just put this stuff all back as zeros. So we're just overdrawing a lot on that one spot. That's fine. Okay, that seemed to work how I was expecting. So we're drawing a triangle. If the W component is 1, we're drawing a quad if it's 0. And what if we had a 2 and we did something else? So else if 2, no, this is 1. Okay. Like for example, what if we wanted to draw a cube? Well, we'll start with 2 planes like this. So one on the floor, like this, and then one standing upright. So I guess we could grab this code. It's going to look the same. So if we're going to do mod 8, because we've got 8 indices in a cube. Yes, 1, 2, 3, 4, 5, 6, 7, 8, yeah. And we're going to have to draw it in a particular order, I think. Let's think about it. So we got, where's my pen? Where's the thing? There we go. Okay. So let's say we start here, and then I think it goes down, then across. So that makes a triangle. And then up, that makes a quad, right? Then I should have done it in 3D. Let's do it in 3D. I'm not sure about the order, but let's just see if we can figure out the idea. So the idea is we draw this one, this one, this one, and that makes a triangle. And then when we draw this one, because we're making a triangle strip, it should connect these. And then we got to draw something like this one. And that will connect these and these, I think. I'm not 100% sure, actually, about the order. It might only connect one side. So why don't we just try that so far? So we'll just draw one up in the air. So say else if index is equal to 4, position, we'll keep this. And we'll say position.y is, which way is up? Plus, I think plus is up. It's confusing because I'm usually working in 2D, and in 2D I always have up is -1. So coming from the top left instead of going from the bottom. All right, let's see. What do we got? Okay, that did not work. We're probably not sending enough. Yeah, we're not sending enough vertices in here, so we need to send 8 because we're going to potentially draw a cube, right? All right, that seems to be not quite what I was hoping for. We've crossed over, so we need to change the ordering here, which is fair. I'm going to color these based on the color, actually, based on the index. So I'm just going to make a color variable, make it green, and then in this particular one I can add color dot, or just color. I guess I'll do, yeah, this one going to be red and green and no blue, so that'll be yellow. This one can be sort of cyan. Okay. Hopefully that colors the triangles a bit. Oh, it did do vertex coloring like okay. It does blend between them. I was just making a mistake earlier, I guess. Cool. So I can see that's the yellow vertex over there, and that's the cyan one. So we actually want to definitely change the order of this. Okay, I should get an idea of what the other ones are. So we'll say the first one can be red, second one can be blue. Actually, that's not the first one. That's the first one. Second one can be blue. The third one can be magenta. So magenta is red and blue, right? Alright, there we go. So red, blue, red in this corner, then blue, and then we're going to magenta. That's okay, that makes sense. That follows that triangle. Hi, do I also stream on Twitch? Cool Coding Cat. Yeah, I should be live on Twitch right now. Am I not? It might have messed up. Let me see. Yeah. So my name on Twitch is, I can't type in here, which is annoying. It's Falconer D. So my last name and then my initial of my first name. Okay, so we got, I forgot the order now. Okay, red, blue, magenta. What is this? Yellow, cyan. Red, blue, magenta. Yep, that's right. Yellow, cyan. Interesting. Maybe we need to change that order. It's actually kind of a weird order now that I look at this one down here. That's a crossover triangle. We don't want a crossover triangle. Hey, nice. Welcome, welcome. Thanks for the follow. Yes, hello Kondo. Kondo Isami. How you doing? Okay, so let's fix this one down here first. So I would have thought, oh, is it because we're doing, let's see what happens. Okay, I got an idea. If we pass in a 4 here, we might get the result that we were expecting. Yeah, for this bottom one. That's what I was expecting. And then for this one, and for this one. That makes sense. However, since we are extending, we don't want to set the position back to 0, I guess. So in here we can say, I guess if index is greater than 3, position equals, we just want to keep it on this one, I guess. So actually I'll just make this greater than or equal to. I think that will work. And then we've got to change this number back to 8. So we're going to overdraw some vertices. You're also playing with SDL and Odin, and so far it's nice. Yeah, I agree. It is nice. Hey, that's not what I wanted. Okay, I'll do one more case. Else if index is greater than 3, position dot x plus equals 1. Nope. No. Okay, maybe we're not going to be able to get the result that I want. But it doesn't really matter. These are just debug shapes. Just being a bit pedantic. So that's all right. There's probably a way, but I'm not sure. In fact, I think this guy, I can't say what's his name? Versidium. I think Versidium actually covered this exact problem. Well, it's a similar problem in this part. So he was talking about these joining vertices, which is not exactly the same as us, but he added an extra triangle to each strip, and then that made them invisible or something. I don't know exactly how that works. So those are connected to here, so that means the... Oh, I get it. Stop going down. Right. I'll have to watch the explanation again, but it's alright for now. We don't have to worry about that just yet. Let's just see if we can get a cube. So I'm going to say we've gone up on the y-axis. Okay, I'm just going to draw the vertices in whatever order. Right now I'm going to do above the magenta one, and then I'll do above the red one, and then above the blue one. So let's see, above magenta, it's going to be here. So basically, that doesn't make sense. That's not magenta. That's magenta. Oh, that's going to annoy me if I read that later. Okay, there we go. Else if... Why did I close it? Magenta, red, blue. Right, magenta, red, blue. Red is default, so we'll say index equals 6. All we want to do is move the y position up. Else, I guess this is the last case for now. I will still put this in here anyway, even though it's not really required. This would be x plus 1, y plus 1. Okay, now let's have a look, shall we? Oop. All right. Okay. Definitely not what I wanted. Okay. However, the bottom part looks better. So we're not crossing over there anymore, but we've gone here, here, and then... Oh, I see. I think I needed to perhaps go back down, and then up, and then down. Let's see, can we draw this out real quick? So I was kind of drawing it here, but I decided to stop. So let's see. I'll just draw a little cube. There. Something like that. Horrible cube, but that'll do. So we want to go 1, 2, 3. That gives us this shape. Then I guess we should go to 4. And then go up. Let's see. So we make a triangle like this. We go around. And then we go across here, which joins these because it's a strip. But then if we go, actually I'm just going to try this, up here and then across. And that should give us this, but it might be connected back down there. 1, 2, 3, 4, 5. It's going to be wrong, but I need to look at it to get my bearings. Okay, 1, 2. Right, so I didn't go around, I went across. Maybe I should have gone around, so... Instead of going to Z, we go to XZ first. No. So this is red, blue, yellow, magenta. Red, blue, yellow, magenta. Yeah, oh, but then everything's connecting back to here because we've got the 8 vertices. So I'm just going to ignore that stand-up triangle going through the middle. And we can look at this one, which is constructing the side. That's correct. So that's teal, which is this one. Then if we go across to whatever's above magenta, we should get a flat back there. So magenta is this one, so we want to go Z plus 1. So we already had that code actually. Z and Y. Okay, we've constructed the back plane correctly. Now we want to go probably... So we're currently up there. If we go across here, oh, that's going to mess up the cube. There's probably an optimal order to do this, hey? If we go across here, then it's going to create a triangle from the bottom corner up. But then we've got to go down, and then... You know, this reminds me of... There's like a children's puzzle where you've got to solve this kind of problem. What is it? I can't remember. I'm getting like vague memories of doing something like this as a kid. You've got to construct something in the correct order. All right. So this is already wrong, I think. Because if we go back down that side, we're not going to get a cube. If we go up over here, we can get like a hollow cube, which might be fine. Is it even possible to do what I want? You know what would be cool? If I had a program that I could draw on a cube. Do I have Blender? Yes. Okay, that's fine. Thank you. Okay, I just want a cube, please. Go away. Alright, can I draw? How do I draw? Annotate? I think there's a mode, right? Like, texture paint. Alright. That's not drawing anything. How do I actually edit it? God, it's been ages since I used Blender. Oh, I have to draw over here? Apparently not. Mix. I don't want to mix. I want to... Okay, I guess I do want to mix. Where's the brush? Radius. We'll turn that down. That's fine. Why can I not actually draw? Do I have to like select it or something? God damn it. Does it not have a right? It doesn't have a texture. Okay, we'll add a texture. Base color. Okay, I can draw on it now. Great. Okay, so let's just pretend, well, let's just use the bottom here. So we're going to draw here, and then we're going to go over here, then we're going to go over here, which is going to make this strip. So that part's fine. And then we're going to be on this side, right? So then we're going to go, let's say we go up. That's going to make this. Then if we go to the right, that should make something like this. Then we're down here and we want to go. See, the problem is now we're in a bad spot, I think. Because if we go up here, let's see. So we go up here and then we can go across to connect these. However, now we've got to go across the top here because we are currently at this position. So let's say we go along here. This is more than 8, isn't it? I think this is going to be more than 8 vertices. Because we might double up on the corners. Okay, you know what I haven't done for some reason? I haven't seen if anyone has already done this. So triangle, strip, cube. Yeah, it looks like, of course, people have already done this. Triangle strip is the best choice for rendering a cube. Here's a blog by Paride Brogi. Here is the old way. And then end up with all these vertices, the optimized way. Okay. So basically the order that we want is this. Hey, Bifask. Bifask? Thanks for the follow. We're not, no, we don't want this. This is using elements. We don't want to use elements. That's fine. We can still, I think we can extract from this by using the elements. So basically just a normal cube. Let me just grab this and I'll put it into a file. I'll just put it in this file, I guess. Okay, so we've got these vertices, let's say. And then if we look at the indices, 1, 2, 3. So 0, 1, 0, 0, 1, 1. And then I'm just going to number these actually. Whoops. I know there's a way to draw a line of numbers in this program, but I can't remember. 6, 7, there we go. So 3, 0, 1, 0, and then 2, 1, 1, 0, then 6, 0, 0, 0, then 7, 4, 2, 0, 7, 4, 2, 0. Okay. 3, 1, 6, 5, 4, 1, 0. Okay, we'll just do this real quick. I'm supposed to go right now, but I have a little bit of time. 3, 1, 6, 5, 0, 0, 1. I'm pretty sure I could have done this a more efficient way. That was 4, and then 1, 0, 1, and 0 is 1, 1, 1. Okay, this is 10. How many is this? Hey Diego, how you doing? This is actually 13. Is that right? 14. So we must have missed one. Which is a little bit unfortunate, because now I've got to convert these again. Maybe the better choice would have been to do something like this. So 3, 2, 6, 7, 4, 2, 0, then 3, then 1, then 5, then 4, 1, 0 again. Okay, now we can edit this. This would be, I guess, position plus equals vec3 I'm gonna have a little bit of a problem here. Whoops, so I'm gonna select this, get rid of those F's, get rid of these commas here. Now there's one line that doesn't have one. There we go. Okay. Right, so now all we do, that's fine, I'll just leave it like that for now. So we grab these and we put them in here and we say, I could just make an array, I guess, actually. It's alright, we'll just do this for now. If index is 1, well, if it's 0 actually, we're doing some, what's that guy's name? Yandere dev guy? Doing some Yandere coding right now. As far as I've heard anyway, I've never looked into it. I messed up. I messed up somehow. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. But somehow I messed it up. Are you kidding me? That's 13. God damn it. Alright. Yeah. Three, 2, 6, 7, 4, 2, 0, 3, 1. I missed a 6 here. Ah. Okay, I'm going to put this in an array now. And we'll call it cube vertices, perhaps. Okay, hopefully that works, and then we can do something like this. Position plus equals cube vertices index. Is it going to work? Hey look, compiled first time. That never happens. Alright, well, we didn't pass in enough vertices. 1 second. We need to pass in 14 for every primitive. That definitely did not work. Well, it's close. It's not quite a cube though, is it? Hang on, is that 13? Son of a... No, it's 14. There's one here. Okay, that's fine. Okay, so we got 14 vertices, but somehow... Oh yeah, this is probably why we need to go up to 14. Hey, would you look at that? We got a little cube for our debug drawing. Our triangles are really overdrawn now. They're using 14 vertices per debug triangle, but that's fine. Actually, there might be a way to early exit. Is there a way to early exit the vertex shader? There might be. I know you can do discard in the fragment shader. So you might be able to do something like else. Does this work here? Discard? Doesn't look like it. It's not a keyword. Error, that's not a thing. Let's just look real quick. It's not supported in this stage, so there's no yeah, but maybe return. Because we're not going to draw this vertex. So we just want to get out of here. No, we don't want to do else. We want to do else if index is greater than 3. Because otherwise we'll catch it on the 0 index as well, which would not be good. Greater than 2. Got to put parentheses in this language. Yeah, so I've basically been working on drawing 3D debug shapes, and I wanted to do it sort of in the shader. So you can see we've got the vertices here, And then we actually don't even use this vertex buffer. I'm going to get rid of it. And we pass in these positions. And the positions are vec4s. And the fourth component of the vec4 determines what mesh we're going to draw. So if it's a 2, we draw a cube. If it's a 1, we draw a square. And if it's a 0, we draw a triangle. I'm probably going to get rid of triangles because, or maybe I'll leave it in there just in case. That's kind of the idea. So that works. I think we're probably not doing too much overdrawing now, hopefully. So cool. That is success. I'm going to actually do one more thing here, which is I'm going to set the position of this. I also want to be able to set the colors. That would be nice. So maybe I'll need another component here. But let's see. So I'm going to set the position of this to light. Where is it? Called light position? Yeah. Of course. Okay, I'm going to draw a cube at the light position. Is it going to work? Yeah, nice. You can see the light's going down. It's coming up. Nice, very cool. Great success. Well, sorry to do this to Diego, but thank you for dropping in. But I'm going to go. I know you were just so excited to catch me live, but alas, I must do things in my house. And yeah, I got to work on the next course module, which is going to be pretty fun. I'm making an RPG. I think that's going to be really interesting. Yeah, anyway, so thank you everyone for coming. I will say this stream is a success in terms of the goal. We have debug shapes drawing on the screen. They can make them move. And that's about it. That's all we needed to do. I would like to draw a sphere at some point in the future, but it's not really high priority. Thank you very much. All right, see you guys later. Take care.